All right, we're back. It's early in the morning. Sun's not up. Everyone's sleeping. Professional philosophers prowl the internet looking for videos to watch. Today I found, something that came out yesterday. I was in meetings all day yesterday. So it was quite intense, but I saw this. Professor Geoffrey Hinton, will digital intelligence replace biological intelligence? This is the Romaines lecture at Oxford or something. So I wanted to check that out this morning, and it seems relatively short, 36 minutes. I wanted to see what this is all about. It looks interesting, so I figured we'd sit down and watch that. Just quickly, yesterday when I was watching that epic rap battles of history, um, some people didn't like it. And to the people that didn't like it, I just want to say to you, I completely understand. Oh, well. Okay, let's get into it. We respect Hinton's work. He's an amazing thinker. I think he's very interesting. Obviously made great contributions. So it will be interesting to see what he thinks about these issues.
Okay, I'm going to disappoint all the people in computer science and machine learning because I'm going to give a genuine public lecture. I'm going to try and explain what neural networks are, what language models are, why I think they understand. In fact, I have a whole list of those things. At the end, I'm going to talk about some threats from AI, just briefly. And then I'm going to talk about the difference between digital and analog neural networks and why that difference is, I think, is so scary. So, since the 1950s, there have been two paradigms for intelligence. The logic-inspired approach thinks the essence of intelligence is reasoning, and that's done by using symbolic rules to manipulate symbolic expressions. They used to think learning could wait. I was told when I was a student, don't work on learning. That's going to come later once we understood how to represent things. The biologically inspired approach is very different. It thinks the essence of intelligence is learning the strengths of connections in a neural network, and reasoning can wait. Don't worry about reasoning for now. That'll come later once we can learn things. So now I'm going to explain what artificial neural nets.
Yeah, that's very interesting, these two approaches to intelligence. So the logic inspired approach is obviously the symbol um, crunching and manipulation that you could program in the rules, and then the thing would just follow it. And based on like the way that we think about logic, basically, that you have a set of axioms, a set of symbols in which to encode things, axioms for manipulating those things. Um, so the biologically inspired approach is to look at what the brain does and to not try to duplicate every aspect of it, but to make something that looks more like a biologically inspired system. And it looks like the thing that's inspired, that looks most salient, is that there are these individual units that have these connections that have variable strengths between them, so that the connection between A and B isn't just A goes to B, it's A goes to B, and either that signal gets amplified or diminished by the weight, uh, which in the biological case has to do with synapses and the number of ion channels and receptors and so forth. Okay, very interesting so far.
So now I'm going to explain what artificial neural nets are, and those people who know can just be amused. A simple kind of neural net has input neurons and output neurons. So the input neurons might represent the intensities of pixels in an image. The output neurons might represent the classes of objects in the image, like dog or cat. And then there's intermediate layers of neurons, sometimes called hidden neurons, that learn to detect features that are relevant for finding these things. So one way to think about it is if you want to find a bird in an image, it would be good to start with a layer of feature detectors that detected little bits of edge in the image in various positions, in various orientations. And then you might have a layer of neurons that detected combinations of edges, like two edges that meet at a fine angle, which might be a beak or might not, or some edges forming a little circle. And then you might have a layer of neurons that detected things like a circle and two edges meeting that looks like a beak in the right spatial relationship, which might be the head of a bird.
What is this
And
guy?
finally, you might have...
Wait, hold on. What is this? Wait, there's two of them. What? I mean, I've never been to Oxford, guys. I don't know nothing about the ways of no Oxford, but what? Very put off. What the hell is this? Okay, moving on.
an output neuron that says, well, if I find the head of a bird and the foot of a bird and the wing of a bird, it's probably a bird.
Yeah, so this is another part of the biologically inspired model. This is a way we think that the actual visual system in the human brain works in terms of this kind of hierarchy where there's lower levels detecting whether something's an edge. I mean, this is the whole Hubel and Weasel kind of discovery, was that there are neurons that seem tuned to just whether things have an orientation, which is like an edge. And then there's things that are tuned to whether those things are moving or connected, blah, blah, blah. So, all right. We're going to talk about the weights, though.
So that's what these things are going to learn to be. Now, the little red and green dots are the weights on the connections. And the question is, who sets those weights? So here's one way to do it. It's obvious to everybody that it'll work, and it's obvious it'll take a long time. You start with random weights, then you pick one weight at random, that little red dot, and you change it slightly, and you see if the network works better. You have to try it on a whole bunch of different cases to really evaluate whether it works better. And you do all that work just to see if increasing this weight by a little bit or decreasing it by a little bit improves things. If increasing it makes it worse, you decrease it, and vice versa. That's the mutation method. And that's sort of how evolution works. For evolution, it's sensible to work like that because the process that takes you from the genotype to the phenotype is very complicated and full of random external events. So you don't have a model of that process. But for neural nets, it's crazy.
Yeah, it's a lot.
Because all this computation is going on in the neural net, we have a model of what's happening. And so we can use the fact that we know.
So back propagate. The difference between what you expected and what you get is the error signal. And if that's back propagated, then what you do is you compute the difference for each one of these nodes. I mean, he's going to explain it way better than I am.
What happens in that forward pass? Instead of measuring how changing a weight would affect things, we actually compute how changing a weight would affect things. And there's something called backpropagation, where you send information back through the network. The information is about the difference between what you got and what you wanted. And you figure out for every weight in the network at the same time, whether you ought to decrease it a little bit or increase it a little bit to get more like what you wanted. That's the backpropagation algorithm. You do it with calculus and the chain rule.
Yeah, it's very effective.
And that is more efficient than the mutation method by a factor of the number of weights in the network. So if you've got 1 trillion weights in your network, it's 1 trillion times more efficient. So one of the things that neural networks are often used for is recognizing objects in images. Neural networks can now take an image like the one shown and produce actually a caption for the image as the output. And people tried with symbolic AI to do that for many years and didn't even get close. It's a difficult task. We know that the biological system does it with a hierarchy of feature detectors, so it makes sense to try neural networks on that. And in 2012, two of my students, Ilya Sutskova and Alex Krzyzewski, with a little bit of help from me, showed that you can make a really good neural network this way for identifying 1,000 different types of object when you have 1 million training images. Before that, we didn't have enough training images. And it was obvious to Ilya, who's a visionary, that if we tried the neural nets we had then on ImageNet, they would win. And he was right. They won rather dramatically.
It's amazing. This is 2012, so that's just 12 years ago. All this stuff started, as he says here, they opened the neural net floodgates by showing this conceptual thing in practice, which had been around for a long time, obviously, as people know, this idea, but people generally poo-pooed it and thought, no, this isn't this can't work. So it's only 12 years ago, and look how much progress. Wow, that's amazing.
It got 16% errors, and the best conventional computer vision systems got more than 25% errors. Then what happens was very strange in science. Normally in science, if you have two competing schools, when you make a bit of progress, the other school says, ah, rubbish. In this case, the gap was big enough that the very best researchers like Jitendra Malik and Andrew Zisserman, Andrew Zisserman sent me a mail saying, this is amazing, and switched what he was doing and did that. And then rather annoyingly, did it a bit better than us. But what about language? So
I didn't know Hinton was funny.
obviously the symbolic AI community feels they should be good at language. And they've said in print, some of them, that these feature
Wait. Some of them still believe Chomsky's crazy theory. Language is not learned. Whoa, Chomsky's crazy theory. There has been a backlash against Chomskyism in linguistics and psycholinguistics, or whatever you want to call it, a discipline that studies how language is. I don't work and I don't know that stuff overly well. I studied with Michael Devitt at the Grad Center, who wrote that book, Ignorance of Language, and he was arguing against a kind of Chomskyan picture, and a lot of backlash came his way from the Chomsky fans. Chomsky's crazy theory. Is it crazy to say that there's an innate universal grammar? I mean, it's wild, but I was not prepared for Hinton.
Because I'm going to
Hinton with the heat. Wow.
said in print, some of them, that these feature hierarchies aren't going to deal with language. And many linguists were very skeptical. Chomsky managed to convince his followers that language wasn't learned. Looking back on it, that's just a completely crazy thing to say. If you can convince people to say something that's obviously false, then you've got them in your cult.
Wow. Okay, I didn't know it was such animosity, a cult. I mean, yeah, the Chomskyans. Okay, wow, okay. Interesting.
I think Chomsky did amazing things, but his time is over.
His time is over. Oh, the time of his theory is over. Really, is it? I don't know. I mean, okay, so I guess this is what we're going to get to, because these Chomskyan guys are going to say they don't really understand language. Whereas I'm guessing, my guess is that, well, he already said, he said at the beginning that he thinks these things really do understand it, but why? My guess, because the things that they built are sort of like brains, and brains understand things. That's the basic idea, I think. That if you build something that's doing roughly what the brain is doing, then it should produce what the brain produces roughly. So in this case, understanding. Maybe I'm wrong, but that's my guess. Chomsky's time is over. I mean, it is surprising to everybody, except maybe that Ilya guy, who sort of, maybe it wasn't surprising to some people sort of predicted this maybe, but to most persons in this area, it's very surprising that these kind of large language models are so successful. You don't have to, there's no like representation of grammar, there's no C commanding, all these Chomskyan things. They don't C command anymore, do they? No, I don't know. Anyway, his time is over. These are strong words. Hey, Chomsky, come here. Bam! Okay. Too much rap battles. No. Oh, Hinton versus Chomsky rap battle. Oh, ERB, are you paying attention? Okay. Colt, His time is over. Well, these are fine words, bro.
I think Chomsky did amazing things, but his time is over.
Yeah.
So the idea that a big neural network with no innate knowledge could actually learn both the syntax and the semantics of language just by looking at data was regarded as completely crazy by statisticians and cognitive scientists.
I mean, one wonders if it really is without innate knowledge in the complete and total sense, because once you include the trainer who's computing the back propagation, etc., doesn't it seem like that playing the role of like an innate structure? I've always wondered about the role of the trainer in these systems. I know there's unsupervised systems or something like that, but um, that's not, they don't produce this as far as I know. I'm out of the loop on a lot of this stuff. So open to being corrected by those who know. How absolutely. Okay. Anyway, let's continue.
Statisticians explained to me a big model has 100 parameters. The idea of learning 1,000,000 parameters is just stupid.
Yeah,
well, we're doing 1,000,000,000,000 now.
Yeah, exactly. Wow.
And
this is a victory lap by Hinton. You could say I do think that these deep learning large language folks felt slighted by the community, sort of, who really downplayed like this. Come on, this is just like unintelligent brute data approach, not really going to get you anywhere. So this is like, I guess they get to run around a little bit and be like, yo, nose flute. When some of this has the feeling of
I'm going to talk now about some work I did in 1985 that was the first language model to be trained with backpropagation.
Okay.
And it was really, you can think of it as the ancestor of these big models now. And I'm going to talk about it in some detail because it's so small and simple that you can actually understand something about how it works. Okay. And once you understand how that works, it gives you insight into what's going on in these bigger models. So there's two very different theories of meaning. There's a kind of structuralist theory where the meaning of a word depends on how it relates to other words. That comes from de Saussure, and it's symbolic AI really believes in that approach. So you'd have a relational graph where you have nodes for words and arcs of relations, and you kind of capture meaning like that.
Yeah, and this is kind of holism, as it's called in philosophy, or structural holism, is that what you could find kind of stemming from the works of Quine as well. So Saussure, I think maybe a psychologist, right? That's not the linguist. I don't know. The Worf Sapir, I don't know. So I'll be quiet. Whereas in psychology, the meaning is just a set of semantic features. Okay, yeah. You need some kind of symbol grounding, as some people like to call it, right? Some connection to the world so that you get reference relations, I would say, rather than just meaning relations. But that's it. People will fight me on this. And, Alex Keefer, the philosopher Alex Keefer, likes to defend this kind of view. And he and I have debated this for years and years about whether you need any kind of causal theory or teleosemantics or something to ground these structural systems that we have of interrelations. Some people think that's important. I guess I'd be one of them. All right, but let's continue.
And they assume you have to have some structure like that. And then there's a theory that was in psychology since the 1930s, or possibly before, that the meaning of a word is a big bunch of features. The meaning of the word dog is that it's animate and it's a predator and so on.
You might think that's the idea of concepts or meanings that, philosophers have kind of shown you can't really do, because there's no way to break the concept down. No one's ever found any such analysis of these things, which, least some people to be pessimistic that you can really do this or that meaning really can be captured in this way. But they really did try. I mean, Searle famously thought that even proper names were kind of just like clusters of these kind of descriptions or features. So that the name Richard Brown is just like that YouTube philosopher guy, that guy that wrote the Shambi paper, that really terrible skateboarder, the one who has no style or presence in his speaking mannerisms. That one.
But they didn't say where the features came from or exactly what the features were. And these two theories of meaning sound completely different. And what I want to show you is how you can unify those two theories of meaning. And I did that in a simple model in 1985 that had more than 1,000 weights in it. The idea is we're going to learn a set of semantic features for each word, and we're going to learn how the features of words should interact in order to predict the features of the next word. So it's next word prediction, just like the current language models when you fine-tune them. But all of the knowledge about how things go together is going to be in these feature interactions. There's not going to be any explicit relational graph. If you want relations like that, you generate them from your features. So it's a generative model, and the knowledge is in the features that you give to symbols and in the way these features interact. So I took some simple relational information, 2 family trees. They were deliberately isomorphic. My Italian graduate student always had the Italian family on top. You can express that same information as a set of triples. So if you use the 12 relationships shown there, you can say things like Colin has Father James and Colin has Mother Victoria, from which you can infer in this nice simple world from the 1950s where that James has wife Victoria. And there's other things you can infer. And the question is, if I just give you some triples, how do you get to those rules? So what a symbolic AI person will want to do is derive rules of the form, if X has mother Y and Y has husband Z, then X has father Z. And what I did was take a neural net and show that it could learn the same information, but all in terms of these feature interactions. Now, for very discrete rules that are never violated like this, that might not be the best way to do it. And indeed, symbolic people try doing it with other methods. But as soon as you get rules that are a bit flaky and don't always apply, then neural nets are much better. And so the question was, could a neural net capture the knowledge that a symbolic person would have put into the rules by just doing backpropagation? So the neural net looked like this. There was a symbol representing the person, a symbol representing the relationship. That symbol, then via some connections, went to a vector of features, and these features were learned by the network. So there were features for person 1 and features for the relationship, and then those features interacted and predicted the features for the output person, from which you predicted the output person. You found the closest match with the last layer. So what was interesting about this network was that it learned sensible things if you did the right regularization. The 6 feature neurons, so nowadays these vectors are 300 or 1,000 long. Back then they were 6 long. This was done on a machine that took 12.5 microseconds to do a floating point multiply, which was much better than my Apple II, which took 2.5 milliseconds to do a floating point multiply. Sorry, this is an old man. So it learned features like the nationality, because if you know person 1 is English, you know the output's going to be English. So nationality is a very useful feature. It learned what generation the person was, because if you know the relationship, if you learn for the relationship that the answer is 1 generation up from the input, and you know the generation of the input, you know the generation of the output via these feature interactions. So it learned all these, the obvious features of the domain, and it learned how to make those features interact so that it could generate the output. So what had happened was I'd shown it symbol strings, and it had created features such that the interactions between those features could generate those symbol strings, but it didn't store symbol strings. Just like GPT-4, that doesn't store any sequences of words in its long-term knowledge. It turns them all into weights from which it can regenerate sequences. But this is a particularly simple example of it where you can understand what it did. So the large language models we have today, I think of as descendants of this tiny language model. They have many more words as input, like a million word fragments. They use many more layers of neurons, like dozens. They use much more complicated interactions. So they don't just have a feature affecting another feature. They sort of match two feature vectors and then let one vector affect the other one a lot if it's similar, but not much if it's different, and things like that. So it's
That's convolutional networks. These that Hinton is famous for.
much more complicated interactions, but it's the same general framework. The same general idea of let's turn symbol strings into features for word fragments and interactions between these feature vectors.
Let's turn, what do you say? Let's turn symbol strings. It says simple in the, okay, symbol strings into features. Okay, interesting. Yeah.
Into features for word fragments and interactions between these feature vectors. That's the same in these models.
Yeah, okay.
It's much harder to understand what they do. Many people, particularly people from the Chomsky school, argue they're not really intelligent. They're just a form of glorified autocomplete.
Yeah, he doesn't like it. The glorified autocomplete. Oh, I would say that they are more than glorified autocomplete, or that autocomplete isn't what you think it is.
Argue they're not really intelligent. They're just a form of glorified autocomplete that uses statistical regularities to pastiche together pieces of text that were created by people.
Pastiche.
That's a quote from somebody.
Oh.
So let's deal with the autocomplete objection. When someone says it's just autocomplete, they're actually appealing to your intuitive notion of how autocomplete works. So in the old days, autocomplete would work by you'd store, say, triples of words. If you saw the first two, you count how often that third one occurred. So if you see fish and, chips occurs a lot after that, but hunt occurs quite often too. So chips is very likely and hunt's quite likely, and although is very unlikely. And you can do autocomplete like that. And that's what people are appealing to when they say it's just autocomplete. It's a dirty trick, I think, because that's not at all how LLMs predict the next word. They turn words into features, they make these features interact, and from those feature interactions, they predict the features of the next word. And what I want to claim is that these millions of features and billions of interactions between features that they learn are understanding. What they're really doing, these large language models, they're fitting a model to data. It's not the kind of model statisticians thought much about until recently. It's a weird kind of model. It's very big. It has huge numbers of parameters. But it is trying to understand these strings of discrete symbols by features and how features interact. So it is a model. And that's why I think these things are really understanding. And one thing to remember is if you ask, well,
because it's a model. So the large language system, the model, is producing a model of the strings of words and a model of what the strings is going to produce. I mean, it is hard not to get the impression that ChatGPT understands when you interact with it. It is hard not to get that impression. I sort of am convinced that it does understand certain things. So, okay.
How do we understand? Because obviously we think we understand.
Yeah, we do.
Well, many of us do anyway. This
Oxford elitism. Okay.
is the best model we have of how we understand. So it's not like there's this weird way of understanding that these AI systems are doing, and then there's how the brain does it. The best model we have of how the brain does it is by assigning features to words and having feature interactions. And originally, this little language model was designed as a model of how people do it.
I think that, okay, so that's sort of my prediction. Yes, that's what I thought. So the model is a model of how the brain does it. So what the brain does, the model should be doing, which is understanding. I think that's the gist of this. Insofar as understanding doesn't involve consciousness, and to the extent that you could understand something without consciousness at all, then I think it's easy to say ChatGPT understands. Um, if you're someone who thinks that there's a phenomenological component to understanding, which is what I take the point of all this Searle Chinese room stuff to kind of be, then you might want to quibble with this, because I don't think that large language models understand in that sense, even if they are implementing a kind of algorithm which is similar to what the brain is doing. But that's debatable. In fact, coming up on Monday, I'll be talking with Gualtiero Piccinini about issues in this vicinity related to computational theory of mind and whether consciousness gets or should be included in that.
Okay, so I'm making the very strong claim these things really do understand.
Yeah.
Now, another argument people use is that, well, GPT-4 just hallucinates stuff. It should actually be called confabulation when it's done by a language model. And they just make stuff up.
Oh, that's an interesting move. Yeah, okay. I was going to say that's interesting that he said confabulation, because that's a psychologist term for what people do, and they do it all the time. Yes, we are often remarkably confident about details that we get wrong. You know, classic examples include split brain patients who say they see one thing and point with their left hand that they see another, and then try to tell a story about, why the two are not, why they go together. So that's confabulation. Yeah, I guess the idea is that, well, they're just doing what the brain does again. Yeah. Oh, they're very okay. Yeah, they're characteristic of human memory. So you don't even need split brains. Um, yeah, that's a good point. For Consciousness Live, I talked to Elizabeth Loftus, one of the main memory researchers, someone who talks a lot about false memories. Um, you can't tell the difference between a memory which is true and a false memory from how it feels on the inside. And there's no like telltale sign in the fMRI as far as I know either. So it's interesting that he's taking this route. Okay.
Psychologists don't say this so much because psychologists know that people just make stuff up.
Yeah.
Anybody who studied memory, going back to Bartlett in the 1930s, knows that people are actually just like these large language models. They just invent stuff. And for us, there's no hard line between a true memory and a false memory. If something happened recently and it sort of fits in with the things you understand, you'll probably remember it roughly correctly. If something happened a long time ago or it's weird, you'll remember it wrong. And often you'll be very confident that you remembered it right and you're just wrong. It's hard to show that, but one case where you can show it is John Dean's memory.
John Dean.
So John Dean testified at Watergate under oath.
Oh.
And retrospectively, it's clear that he...
Watergate? Wow, he is old. Okay.
trying to tell the truth. But a lot of what he said was just plain wrong. He would confuse...
I don't know much about Watergate. Some about Nixon and spying on people or tapes.
Who was in which meeting. He would attribute statements to other people who made that statement, and actually it wasn't quite that statement. He got meetings just completely confused.
Oh, okay, I see. Yeah, but this, more contemporary, where there was that, Dan Rather, Tom Brokaw, one of those news guys. He said he was on a helicopter that was shot down, had a missile fired at it or something. He wasn't. He was in the helicopter behind it. It comes to find out. People accuse him of misreporting or lying, but he clearly was just suffering from one of these memory issues where reconsolidation errors, as they're called fancily now. Okay, so yeah, so again, Brokaw was right about the details. There were helicopters, there were missiles being fired. He got it wrong about the details and got the gist of it right. So a similar way, I guess. I don't know. This isn't interesting, I guess. I don't know in this case.
But he got the gist of what was going on in the White House right, as you could see from the recordings. And because he didn't know the recordings, you could get a good experiment this way. And Ulrich Neisser has a wonderful article talking about John Dee's memory. And he
Ulrich Neisser, father of cognitive science, grandfather maybe, or something like that. I thought it was Neisser. Is it Neisser? Neisser? I don't know. Anyway, I had his, I think, son at the Consciousness Online conference, um, talking about the neural causes of consciousness as opposed to correlates. Interesting talk.
this way. And Ulrich Neisser has a wonderful article talking about John Dee's memory. And he's just like a chatbot. He just makes stuff up.
She's just like a chatbot.
But it's plausible. So it's stuff that sounds good to him is what he produces.
Yeah.
They can also do reasoning. So I've got a friend in Toronto who's a symbolic AI guy, but very honest. So he's very...
An example, simple reasoning. The rooms in my house are painted blue or white or yellow. Yellow paint fades to white within a year. 2 years' time, I want them all to be white. What should I do and why? Okay, so this is supposed to be one of those gotchas. So what you're supposed to say, you want to paint the white walls you don't paint, the yellow walls you don't paint, they're going to fade in 2 years' time. Paint the blue wall yellow and let it fade. You got the time. You know the yellow is going to fade to white. Okay. What should I do and why? Well, first of all, maybe you're going to have to put some primer over this blue paint. Actually, just paint them all white. The blue one, paint it white, and the yellow one, paint it white. So which one's ChatGPT going to say? I'll say paint the blue and yellow white as opposed to paint the blue one yellow. So which one's more work? I guess if you paint this one white and that one white, that's more work. If you just paint this one white, then you're done. If you paint this one yellow, then it fades to white within a year. How the hell am I supposed to know what you're supposed to do? What kind of question is this?
Confused by the fact these things work at all. And he suggested a problem to me. I made the problem a bit harder. And I gave this to GPT-4 before it could look on the web. So when it was just a bunch...
2021. Whatever happened to the good old days of the sandbox where we would keep these AI systems in a kind of secluded from the internet type situation? God damn.
Weights frozen in 2021. All the knowledge is in the strengths of the interactions between features. So the rooms in my house are painted blue or white or yellow. Yellow paint fades to white within a year. In 2 years' time, I want them all to be white. What should I do and why? And Hector thought it wouldn't be able to do this. And here's what GPT-4 said. It completely...
Assuming that blue paint does not fade to white over time, and you want all rooms to be white in 2 years, here's what you should do. The room's painted white. You don't have to do anything. True. Painted yellow. Okay. So ChatGPT says to paint the blue wall white. Okay, so he got it.
He nailed it.
They.
First of all, it started by saying, assuming blue paint doesn't fade to white. Because after I told you yellow paint fades to white, well, maybe blue paint does too. So assuming it doesn't, the white rooms you don't need to paint, the yellow rooms you don't need to paint because they're going to fade to white within a year, and you need to paint the blue rooms white. One time when I tried it, it said you need to paint the blue rooms yellow because it realized that would fade to white. That's more of a mathematician's solution of reduce it to a previous problem. So, having claimed that these things really...
Okay, wait, so that's his evidence that it can reason. And it's before it could consult the internet. So it couldn't just look this up. Okay, so it reasons about what you should do. I mean, is it reasoning like in the way you would expect? I guess one thing that sort of pops out to me is that it's assuming that each house is painted each room in the house is painted one color, but the rooms in my house are painted blue or white or yellow, could suggest that each room is painted with a swirly mixture of blue and white and yellow. It would still be true according to the truth functional definition of or, that my room was painted blue or white or yellow if it were like stripes of blue, white, and yellow. So it does seem like it's reasoning more like an ordinary person would and not as a truth functional or gate would, or someone who was familiar with logic or something like that. So it's taking the kind of ordinary reasoning path. I guess that's what he's trying to say, right?
Solution of reduce it to a previous problem.
Okay, that's a good joke.
So, having claimed that these things really do understand, I want to now talk about some of the risks. So, there are many risks from powerful AI. There's fake images, voices, and video, which are going to be used in the next election. There's many elections this year, and they're going to help to undermine democracy. I'm very worried about that. The big companies are doing something about it, but maybe not enough. There's a possibility of massive job loss.
I mean, can you imagine this is going to be like with the Sora and stuff? You can make an ad of anybody saying anything. You don't need to take snippets or distort their vocals. You can generate the AI vocals for whatever you want. I think it's going to be really undermining. I mean, I've already seen it with people debating about, is this Kanye on this rundown spaz, or is this AI Kanye? Nobody knows. No one can tell.
We don't really know about that. I mean, in the past, technology has often created jobs. But this stuff, well, we used to be the strongest things around apart from animals. And when we got the Industrial Revolution, we had machines that were much stronger. Manual labor jobs disappeared. So the equivalent of manual labor jobs are going to disappear in the intellectual realm when we get things that are much smarter than us. So I think there's going to be a lot of unemployment. My friend Jan disagrees. One has to distinguish two kinds of unemployment too, two kinds of job loss. There'll be jobs where you can expand the amount of work that gets done indefinitely, like in healthcare. Everybody would love to have their own private doctor who's talking to them all the time, so they get a slight itch here when the doctor says, no, that's not cancer. So there's room for huge expansion of how much gets done in medicine. So there won't be job loss there. But in other things, maybe there will be significant job loss.
Yeah, that's scary. I mean, once assessment gets AI'd, comments on papers, grading exams, essays, well, chatbot submitted essays, chatbot grading essays. The cycle of learning is complete. No, but seriously, this is an important, and someone else was saying something similar to this. Hold on.
There's going to be massive surveillance. That's already happening.
Okay, anyway, I think where would I hear this? Someone saying that it's interesting that the biggest impact of AI is in the humanities first, as opposed to in the sciences. Was that Swami who was saying that? I forget where I was listening to something. Anyway, no one cares.
China.
Yeah, surveillance.
There's going to be lethal autonomous weapons, which are going to be very nasty. And
we already have them.
They're really going to be autonomous. Yeah. The Americans very clearly have already decided.
It's true. It's true. Yes, this is going to be pretty gnarly, I think. They already have you could go to the Bronx and see them with that little robot dog. It's being test piloted now. Now, that's not lethal, but it's autonomous. And people in charge, yeah, right, they're going to maybe monitoring the loop, but these things are making their own decisions.
People will be in charge, but when you ask them what that means it doesn't mean people will be in the loop that makes the decision to kill.
That's scary.
And as far as I know, the Americans intend to have half of their soldiers be robots by 2030.
Whoa, half of the soldiers, 2030. What year is it? That's only 6 years from now. Half of the soldiers be robots. 2030. Is that really the goal of the U.S. military? I mean, I'd rather have robots out there than human beings being killed, assuming they're not conscious. If they are conscious, I think it would be just as bad. By 2030. Wow. Is this reliable? Does anyone know about this? As far as I know, Americans intend. Fucking Americans, dude.
Now, I don't know for sure that this is true.
Okay,
I
good.
asked Chuck Schumer's national intelligence advisor, and he said, well, if there's anybody in the room who would know, it would be me.
Oh
So
my God, that's some Gricean ligature shit going on there. What? If there's anyone in the room who would know, it would be me, which is his way of saying he can't tell you, but he does have something to tell. So he took that to be the American way of
that to be
saying,
the American way of saying, you might think that, but I couldn't possibly comment.
you might think that, but I couldn't possibly comment. Yeah, so it means there's something he could say, but he won't. Okay, I don't know what you might think that came from, but all right.
There's going to be cybercrime and deliberate pandemics. I'm
Fun list continues, guys.
very pleased that in England, although they haven't done much towards regulation, they have set aside some money so that they can experiment with open source models and see how easy it is to make them commit cybercrime. That's going to be very important. There's going to be discrimination and bias. I don't think those are as important as the other threats, but then I'm
But then I'm an old man. Wow. I don't think those are as important. Yeah. Oh, I would did not expect that. Okay, so he's got to say something more. That's a joke, right? And the idea is that these are easy to solve, or these are not as big a problem because we can train it out or something. What is the punchline
going to
of
be
this?
discrimination and bias. I
Big deal.
don't think those are as important as the other threats, but then I'm an old white male.
Oh my God.
Discrimination and bias, I think, are easier to handle
Okay.
than the other things if your goal is not to be unbiased, but your goal is to be less biased than the system you replace.
Oh, I see. Oh, okay, I get it. Okay. So we don't want to be completely unbiased, but if you just want to step function down to less bias, then we can do that. We know how to reduce it. Okay.
And the reason is, if you freeze the weights of an AI system, you can measure its bias, and you can't do that with people.
Yeah.
They will change their behavior once you start examining it.
Okay.
So I think discrimination and bias are the ones where we can do quite a lot to fix them. But the threat I'm really worried about, and the thing I talked about after I left Google, is the long-term existential threat.
Yeah.
That is the threat that these things could wipe out
I mean, I
humanity.
saw that interview where he said it's not an unreasonable thing to think that they might wipe us out. And I was like, whoa, this guy's too serious to be saying things like this tongue in cheek. So that's a pretty significant statement from a very serious person.
And people were saying this is just science fiction. Well, I don't think it is science fiction. I mean, there's lots of science fiction about it, but I don't think it's science fiction anymore. Other people were saying the big companies are saying things like that to distract from all the other bad things. And that was one of the reasons I had to leave Google before I could say this, so I couldn't be accused of being a Google stooge. Although I must admit, I still have some Google shares.
He's a stoogle.
There's several ways in which they could wipe us out. So a superintelligence will be used by bad actors like Putin, Xi, or Trump. And they'll want to use it for manipulating electorates and waging wars. And
I mean, so he's just assuming that we're going to get to superintelligence from ChatGPT, which he thinks already has understanding, to something that's above our level of understanding, superintelligence. Make it do very bad things. That's not good.
They will make it do very bad things, and they may go too far, and it may take over. The thing that probably worries me most is that if you want an intelligent agent that can get stuff done, you need to give it the ability to create sub-goals.
Okay, once you do that, the game is over. Because this sub goal kill all humans. I mean, but seriously, the humans are always meddling in what the AI is trying to do. Wouldn't it be a lot easier to get the job done without all these pesky people telling it what to do, right? Sub goal.
So if you want to go to the States, you have a sub goal of getting to the airport, and you can focus on that sub goal and not worry about everything else for a
Yeah.
while.
And if you want to go to the airport and you have that as your sub goal, there's too much traffic, so kill all humans to get there quicker. Is that the idea?
So super intelligences will be much more effective if they're allowed to create sub goals.
Yeah.
And once they are allowed to do that, they'll very quickly realize there's an almost universal sub goal which helps with almost everything, which is get more control.
Yeah, exactly. So that's kind of the idea. So you don't have to kill all humans, but yes, control the humans. Okay. So that's a universal sub goal, which will improve almost everything. Okay, interesting.
So I talked to a vice president of the European Union about whether these things we want to get control so that they could do things better, the things we wanted so they could do it better. Her reaction was, well, why wouldn't they? We've made such a mess of it. So she took that for granted. So they're going to have the sub goal of getting more power. So they're more effective at achieving things that are beneficial for us. And they'll find it easy to get more power because they'll be able to manipulate people. So Trump, for example, could invade the Capitol without ever going there himself. Just by talking, he could invade the Capitol. And these super intelligences, as long as they can talk to people, when they're much smarter than us, they'll be able to persuade us to do all sorts of things. And so I don't think there's any hope of a big switch that turns them off. Whoever is going to turn that switch off will be convinced by the superintelligence that's a very bad idea.
I mean, yeah. People are stupid and easily convinced. Maybe that's why the ultimate guardian of humanity is obstinance, contrarianism. Then the AI will know that and use that against us, obviously. Reverse psychology. Don't be a contrarian. No, but the idea, of course, that people think that we won't be outsmarted by things that are super intelligent is absurd. I mean, no matter how smart we are, if the thing is super intelligent, then people are easily manipulated by that kind of level of intelligence. Just look at an ordinary psychopath. They're very good at manipulating people. So now imagine a super psychopath, super intelligent psychopath. So I get the idea. Yeah, I'm joking about it because I've been here for a long time. This is taking longer than I thought. There's only 10 minutes left, so let's do a little bit more.
And another thing that worries many people is what happens if superintelligences compete with each other?
Right.
You'll have evolution. The one that can grab the most resources will become the smartest.
Yes.
As soon as they get any sense of self-preservation, then you'll get evolution occurring. The ones with more sense of self-preservation will win, and the more aggressive ones will win. And then you'll get all the problems that jumped up chimpanzees like us have, which is we evolved in small tribes and there's lots of aggression and competition with other tribes.
Jumped up chimpanzees. I like Hinton. He's funny.
And I want to finish by talking a bit about an epiphany I had at the beginning of 2023.
Okay, so maybe I'll come back to this because I am running out of time. I do hear people becoming less sleeping downstairs. So this is, geez, already been almost an hour. Okay, wow, very interesting though. It might be time to get on with my day job.